zeros of transcendental equations using bisection method. At the end of this lesson, you will be able to describe the bisection method to find the zeros of an equation, define transcendental equations, and solve problems to find the zeros of transcendental equations using bisection method. Introduction to bisection method. Using mathematical modeling, most of the problems in engineering and physical sciences can be formulated in terms of system of linear or nonlinear equations, ordinary or partial differential equations, or integral equations. In majority of the cases, the solutions to these problems in analytical form are non-existent or difficult for direct interpretation. When this occurs, we turn to numerical methods to approximate the solution of the given function. There are many numerical methods as displayed on the screen, in which bisection method is used to find the roots or zeros of an equation of the form f of x is equal to 0. Applications of bisection method. Let us see an example of such a need from a real-life problem. To make a fulcrum, a long steel shaft called the trunnion is shrink-fit into a steel hub. The trunnion has to be cooled before it is shrink-fitted into a steel hub. This is done by first dipping the trunnion in a cold medium such as a dry ice or alcohol mixture. After the trunnion reaches the steady state temperature of the cold medium, the trunnion's outer diameter contracts. The trunnion is taken out of the medium and slid through the hole of the hub. When the trunnion heats up, it expands and creates an interference fit with the hub. If the trunnion is not contracted enough to slide through the hole, then it may get stuck, which would result in waste of production cost and delay in production. The function as displayed on the screen gives the temperature T to which the trunnion has to be cooled to obtain the desired contraction. Using the bisection method of finding the zeros, we can find the temperature T to which the trunnion has to be cooled to fit into the hub. Let's discuss about the bisection method. The bisection method is a numerical method for estimating the roots or zeros of an equation of the form f of x is equal to 0. This method helps to narrow down within the given interval a, b to find the zero of an equation. We can also define the bisection method as follows. If f of x is continuous between a and b, and f of a and f of b are of opposite signs, then there is a root c between a and b. Let us discuss on how to find the roots of an equation using bisection method. For definiteness, let f of a be negative and f of b be positive. Then, the first approximation to the root, say x1, is as displayed on the screen. If f of x1 is 0, then x1 is a root of f of x. Otherwise, the root lies between either a and x1 or between x1 and b based on whether f of x1 is positive or negative. If f of x1 is positive, then root lies between a and x1. If f of x1 is negative, then the root lies between x1 and b. Let's take f of x1 as positive. Then the root lies between a and x1. Then the second approximation to the root is, if f of x2 is negative, the root lies between x1 and x2. Then the third approximation to the root is, bisect the interval as before and continue the process until we obtain the solution of the given equation. Problem to find the root of a transcendental equation. The equation we choose in bisection method may be an algebraic equation of degree n, or it may be a transcendental equation. An equation which contains algebraic terms is called an algebraic equation. An equation which contains trigonometric ratios, exponential functions, or logarithmic functions is called as a transcendental equation. In this lesson, let us discuss a problem to find the zero of a transcendental equation. Find an approximate real root of the equation x into sin x is equal to 1 between 1 and 1.5 by bisection method in 4 iterations. The given equation can be written as displayed. The graph of this equation is given as displayed. It is clear from the graph that there is a root that lies between 1 and 1.5. First, let a be 1 and b be 1.5. Let's substitute the value of x as 1 in the given equation. We get the value of f of 1 as minus 0.1585, which is lesser than 0. And the value of f of 1.5 is 0.4962, which is greater than 0. Therefore, the root lies between 1 and 1.5. Now, we can find the value of x1 as given on the screen. And the value of f of x1 is 0.1862, which is greater than 0. Therefore, the root lies between 1 and 1.25. The second approximation of the root x2 is, and the value of f of x2 is displayed on the screen, which is greater than 0. Therefore, the root lies between 1 and 1.125. The third approximation of the root x3 and value of f of x3 are displayed on the screen. Since f of x3 is less than 0, the root lies between x2 and x3. The fourth approximation of the root, x4, is displayed on the screen. Hence, the desired approximation to the zero of the given transcendental equation is displayed on the screen. Conclusion. Thus, in this lesson, we've learned to find the zero or root of transcendental equations using bisection method. Let us summarize what we have learned. An equation which contains trigonometric ratios, exponential functions or logarithmic functions is called as a transcendental equation. The bisection method is a numerical method for estimating the roots of a transcendental equation of the form f of x is equal to 0. If f of x is continuous between a and b, and f of a and f of b are of opposite signs, then there is a root c between a and b.